Thank you. Let's figure out how this works. All right. I want to talk to you guys about the NANOG ring, what it is, how you can use it, and the second half of the talk is about a recent feature we introduced that I consider one of the most awesome things we've done on the ring project in the last few years. The metaphysical definition of the ring is, in essence, that it's a network debugging platform operated by network operators, designed for network operators like yourself. The foundation is based on trust. You provide a machine with access to others, and then you get access to machines that other people made available as well. And so far, a lot of people have already joined. Can I see a show of hands of people that currently have a ring node? Yes, Kate? Very good. So I see a lot of people that did not raise their hands. We need to maybe work on that, and I hope this talk will convince you to join the project. Keep in mind, it's free. The NANOG ring started in 2010 when a friend of mine had a weird issue. From certain source IP addresses to certain destination IP addresses, packets didn't pass through a certain internet exchange, and he was trying to nail down where the issue lay exactly. So he would call people and ask them to do ping sweeps. He asked people on IRC to do trace routes for him. And all of this debugging information was gathered in an asynchronous way, and it consumed an awful lot of time. You probably recognize the scenario where a customer tells you, I have a certain issue. You ask them for a trace route, and they provide you the trace route without any timestamp. Or even better, they put a screenshot of the trace route in a Word document and email that to you. So the ring addresses this type of issues, because we all know debugging networks is not trivial, and the ring helps in that regard. Current state of the ring is that there are almost 300 organizations participating with as much nodes spread over 50 countries or so. So there's a gigantic amount of diversity to assess your network situation from the outside. The ring, as I said, you provide a machine, and in exchange for providing that machine, you get access to all other machines that are part of the ring project as well. Example usage of things you can do with the ring is debug any custom name servers, because the gigantic amount of diversity in the ring will make it very easy to query DNS servers from lots of locations. You can do trace routes from an insane amount of nodes. You can do MTU testing for both v4 and v6, port scanning, and debugging load balancing issues, where the ring originally started with. And now let's cover the new Ring SQA tool that I'm very excited about. Ring SQA is a tool to very fast detect partial outages in your network. You might have some monitoring boxes outside your network, but they only monitor from a single location. And if the path between that location and your network is functional, then you will not see outages. 100% outages are very easy to detect. Your mother will call you and say, I cannot check my email, something is wrong with your network. That's easy. But what if you can only not reach, say, 2 or 3% of the routing table? That's much harder to detect, and that's what Ring SQA will help you do. The process is simple. Ring SQA will detect an issue, and we'll cover how it detects issues later. It will collect data for your immediate consumption, so you have actual debugging information when the issue was occurring, so you don't have a trace route that's hours after the event. It will be trace routes during the event. And then an alarm is emitted. We have various output plugins. You can either get it through email or a UDP packet, which contains the debugging information, or you can launch a shell script which does API calls or opens a ticket. The detection part. Every ring node runs the SQA daemon, and what it does every 30 seconds, it will probe all other nodes to test for reachability. It does so both on V4 and V6. And from this constant probing of all the nodes that are in the ring, it derives a sort of baseline. Because at any given moment, there are ring nodes that are unreachable or rebooting or something is going on. So it's kind of natural to have a sort of noise in unreachability. But what's not natural if suddenly there is an increase in the amount of nodes that are unreachable. And Ring SQA is designed to detect these spikes of unreachability. So every 30 seconds, it probes nodes, it creates a baseline, and if the last 3 minutes, the median of that, is higher than the previous 27 minutes, it will conclude that something is wrong with your network. And this is to visualize what any-to-any probing means. This is really on a scale of 300 nodes. When the alarm is raised, immediately MTRs, or trace routes, are launched to nodes that were previously reachable but are not reachable anymore. And these trace routes are launched in hopes of catching the point where something broke. So it could be leading you towards an internet exchange, or it might be that the 3 nodes that previously were reachable but not anymore share a common upstream. And these trace routes might help you identify that, because you get, it's nice to have alarms, but it's also very useful to at least have a direction to go search for the outage. I would like to stress that in the market, nobody else has a service like this, and especially not for the beautiful amount of $0. You cannot buy this, you can only get it for free. Let's go over a certain example of what an SQA alert could look like. A certain large network had an incident where an important router rebooted, and this created a partial outage for a specific company. The alert will give you the exact timestamp at when it occurred, and a list of nodes that were previously reachable but not anymore. So in the lower half, you see the host name and IP address, AS number, country, all in hopes of that you as a human, when you view this alert, might be able to deduct, hey, that's interesting. Suddenly all these German nodes became unreachable, so you start searching in the German area rather than somewhere else. The trace routes I mentioned are included in that alert. These trace routes all have a certain provider in common that had the actual outage. But the trace routes, they're a guess. The system is not as smart as you engineers, and it's purely designed to, well, it's a guess. And at the end of the email, you will see the ring buffer. 30 minutes of measurements are stored in a circular buffer. The last 3 minutes are compared to the 27 minutes before that. And from that, you might derive something as a human being as well. With this alert, you then know exactly which provider to shut BGP sessions or which router to give a kick, or at least that's the intention of it. If you already are a Ring participant, then you can very easily enable alerting today. Just log into your box, edit /etc/ringsqa/alarm.conf, put in your email address, restart the daemon, and you're good to go. The daemon takes roughly 30 minutes to warm up to collect that baseline, but after that, it will stand guard over your network and alert you when something is up. How would you actually use SQA alerts? At NTT, for instance, we route the alerts to the on-call guys. That's a possible method. Just forward it to your NOC and have them take care of it. Or you code something that you get a text message. That's up to you. So far, we have not really seen false positives at all, which I think is kind of amazing for a statistical tool that we invented like that. What we have seen is transit providers that have core routers that reboot, that affect everything. IXP maintenances, for instance, DKIX did maintenances a couple of months ago, half a year ago, and every time Ring SQA alerts were emitted from German nodes. DDoS attacks, when the lines are congested, the SQA probes don't pass through the lines as easily as the rest of the traffic. So that's something we see often. Or it's a local problem where, for instance, the top of rack switch has an issue and Ring SQA thinks that the network is broken. So in any regard, when Ring SQA emits an alert, I recommend that you take it serious. So far, 0 false positives. So this means that you should put a Ring node in your major locations, because Ring SQA will monitor the network from its own vantage point. So if you have a few major sites, I recommend that you put Ring alerts in all of them, because each site has a slightly different view of the routing table, of course. About the Ring itself, as we are driven by volunteers, there's no money involved. There is a non-profit foundation that is the legal entity behind this. The tools come from Ring participants themselves. So the Ring SQA tool has been written by Iti Saku, or Saku Iti. I always forget which one goes first, from TDC. And you can write software as well if you're interested. This is the way the Ring evolves. It's by active participation from the participants themselves. You can join very easily. Just fill in the application form on our website. The requirements are simple. You provide a virtual machine with one IPv4 and one IPv6 address with at least 512 megabytes of RAM and a 20 gig disk. You have to put Ubuntu on it because that's where we standardized. And you have to have an AS number that is present in the default free zone because it's for network operators. And that's it. It's very easy to join. And as I said, nobody else can offer you this for free. Yep, that's my last slide. Are there questions about Ring SQA or the Ring in general?
It's not working. Oh, it's working. Alexander Levin speaking. 2 questions. First, scaling. How well your instrument scales? How many nodes can accept? Any estimates?
Currently, our growth rate is roughly 1 participant per week. And I see no reason why that would suddenly go up. Because we've been operating for 4 years now. And this is apparently how fast we grow. So at 50 nodes per year, it's still very easy to do any-to-any probing. It's not an issue.
And second is security, external and internal. Internal is if not all of the nodes will cooperate, and some of them will send bad information, somehow malformed information. And the other is how the patching for the whole system works, because you put in something in your infrastructure that you're not completely control.
Good point. From a security point of view, I'd view a Ring node as like a dedicated server you sold to a customer. The difference being that you don't get revenue from the Ring nodes, but security-wise, it's just a third-party element in your network. So for companies that are not all companies are capable of easily putting a third-party device in their network. What I recommend is you put the node close to your edge router, put an ACL on the edge router's interface to protect your internal stuff, so the ring node can never query your internal APIs. But other than that, just consider it a customer. So far, in 4 years, we have not had a single case of abuse of the ring. And I do warn people, if you abuse the ring, I will name and shame you, and that might not be pretty. But so far, this system of trust seems to work. 4 years without incidents, and I don't see why we would not trust each other as adults. Does that answer your question?
It's more inviting the trouble than asking my question. But thank you.
Any other questions? Please come to the mic.
My name is Murad from University of Colorado Boulder. I just have a question. How easy to integrate new matrix to your to Ring? Like if I want to do like new tests and new measurements, is it easy for outsider to add that?
There are two ways to run tests. The first one is you use something like Ansible or an SSH multiplexer to run your scripts on all nodes. Should your measurements be of sufficient generic interest to Ring participants, I would take your measurement software, package it, and then distribute it to all nodes from our configuration management system. So either you make a general purpose tool and we'll package it as part of our distribution, or you just run it through SSH yourself.
All right, thank you.
No more questions? All right. I hope many of you will join the Ring and enjoy awesome network debugging. Thank you for your time.